Hello students, in today's class we will start with the new chapter, that is P block element. In previous classes we were discussing about the S block element. In today's class we will start with one more, that inorganic chapter, that is P block elements. Before going to the P block elements and the objective of that P block element, we need to know what are the P block elements. Later we will discuss about the other things about the P block elements. So hope you know the meaning of P block element. The periodic properties we were discussing in a third chapter. So there we were discussing about how the periodic elements are classified into four blocks. Those are S, P, D, F. We completed the S block element, and now we will discuss about the P block elements. Here the last electron or the valency electron, or you can call this one as a differentiating electron present in the P subshell, that elements are called as the P block elements. That we written here, the elements in which the last are valency electron. So konedata valency electron, in the sense the electrons present in the last shell, those are called as valency electron, enters into the outermost P orbital. If it is present in the P orbital or P subshell, that we are calling as a P block element. Same definition we were discussing in S block elements. That is the last R valency electron is present in the S subshell. Those are called as S block element. Here last electron or the valency electron is present in the P orbital or P subshell. That is called as a P block element. The general electronic configuration of the P block element. We already know that where the P block element will be there in periodic table. Hope you know the periodic table. So this is the periodic table. Here it is. These two are the S block element, and these are the S block element, these are the D block element, these are the P block element here. So that is P block element at the right side of the periodic table. So these are the P block element. Here F block element will be there. This is a grammatical representation about the periodic table, that is S block, D block, P block. The general electronic configuration of the P block will be noble gas NS2 NP6. Here it is noble gas, we have to write noble gas and NS2 NP6. N is the outermost shell here, number of principal cell 1, 2, 3, 4 like that. NP 1 to 6. It means in the P block, that is 13 to 18 will be there. The group elements 13 to 18. Later we will discuss that one. Now it is here P1, P2, P3, P4, P5, P6. That we are writing as NP 1 to 6. NS2 S orbital fully filled irtada. P orbital ದಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ಒಂದೊಂದು ಹೆಚ್ಚಿಗೆ ತುಂಬಿಕೊಂತ ಹೋಗ್ತೀವಿ, ಎಡದಿಂದ ಬಲ್ಕ್ ಹೋದಂಗೆಲ್ಲ. ಇಲ್ಲಿ P1 to P2, P3, P4, P5, P6 like that. Hence we are writing at NP 1 to 6. N represents periodic number, that is 2 to 7 here. That as 6 electrons can be accommodated in the P subshell, there are 6 group present in the P block. P subshell daga total R electron ಹಿಡಿಸ್ತಾವ maximum. ಅದಕ್ಕೆ P block elements ಅನ್ನ R group ಆಗಿ ಏನ್ ಮಾಡಿವಿ, divided ಮಾಡಿವಿ. That is the meaning here. The P orbital can accommodate maximum 6 electron. Hence the P block elements can be classified into 6 groups. And the elements belonging to the P block, that will be 13 to 18 group, that we are writing here. 13 to 18 constitute the P block in the periodic table. 13 ರಿಂದ 18ನೇ ಗ್ರೂಪ್ ಇನ್ ತನಕ ಅವಕ್ಕೆಲ್ಲವಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ P block element ಅಂತ ಕರಿತೀವಿ. Like we were discussing about the S block 1 to 2. 1 ಮತ್ತು 2ನೇ ಗ್ರೂಪ್ ಅನ್ನ S block ಅಂತ ಕರೆದಿವಿ. Here 13 to 18 groups are called as the P block elements. Now that groups, that is the 13 to 18, we written in the slide, that is 13th group, that is we are calling as a boron family. So that the first element of that 13th group will be boron, that we are calling as boron family. And the 14th group, that is a carbon family. 15th group, that is a nitrogen family. 16th group, that is a oxygen family. 17th group, that is a halogen family. 18th group, those are the noble gases. Now it is The general electronic configuration of what it is? Boron family are carbon, nitrogen, oxygen, halogen and noble gases. Now it is ns2np1. So atomic number of boron. So later we will discuss about the atomic number also. Now it is ns2np1, ns2np2, ns2np3, ns2np4, ns2np5, ns2np6. Here the increased electrons are filling in the p subshell, hence these are called as a p block element. Here one electron is p, second electron, third electron, fourth again. The number of electron increases as b, atomic number is increases. Those electrons are filling in the same subshell, that is a p subshell. Here 1, 2, 3, 4, like that. The general electronic configuration of that family we are talking. In first PU we will discuss about the only 13 and 14 groups, and in second year, that second PUC will discuss about the 15 to 18 groups. So in today's class or in P block element of first PU we will discuss about the 13 and 14 groups. Next about the boron family, the group 13 elements, that is called as the boron family. So the elements of 13 groups are collectively called as boron family. ಈ 13ನೇ ಗ್ರೂಪ್ ಅನ್ನ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ collectively ಏನಂತ ಕರೀತೀವಿ ಅಂದ್ರೆ boron family ಅಂತ ಕರೀತೀವಿ. ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಆಫ್ that group, that is a boron family, that is a boron, aluminium, gallium, indium and thallium. These are the 13 group elements: boron, aluminium, gallium, indium and thallium. So boron is a non-metal, and apart from the boron in the 13 group element, those are all metals. Aluminium is act as a amphoteric nature also, that the gallium is a metal, indium is a metal and thallium is also metal. This about the boron family, on the boron is a non-metal, apart from the boron those are all metals. And general electronic configuration of the boron family, now we will discuss that. That is, we written elements here and the symbol of that element and the atomic number, that is denoted by the Z, and here we have written a electronic configuration of that boron family. So very simple about the to remember the atomic number of this one is boron having atomic number 5, 5 plus 8 that is 13, 13 plus 18 that is 31, 31 plus 18 that is 49, 49 plus 32 that is 81. The pattern about the atomic number of this 13 group will be, that is 8, 18, 18, 32. In case of S block we discussed that about the shortcut regarding the remember to atomic number 8, 8, 18, 18, 32. Here it is P block shortcut is 8, 18, 18, 32. For 13 to or it is 17th group we can use this shortcut to remember the atomic number. So that is 8, 18, 18, 32. This is the atomic number of boron we written here: 5, 13, 31, 49, 81. So first we have to write the noble gas, that is a helium 2s2 2p1. 5 will be there. Here it is 2, 2 plus 2 4, 4 plus 1 5. So that we can write that neon 3s2 3p1. Argon 3d10 4s2 4p1. Remember the point here, 3d subshell will be there, and krypton 4d10 5s2 5p1, and xenon 4f14 5d10 6s2 6p1. This is a general electronic configuration. The point here is that the last electron is present in the p subshell. Here it is p subshell, here it is p subshell. In all the cases the last electron is filled in the p subshell, hence these are called as the p block elements. This is the general electronic configuration of the p block element, that is the boron family. And now we will discuss about the physical properties of the boron family and also chemical properties of the boron family. Let us begin with the physical properties of the boron family, that is we will discuss about the atomic radius and ionic radius and also ionization enthalpy. Let us begin with the first atomic, that is a physical property, that is atomic and ionic radii. Hope you know that as we move from top to bottom in a periodic table, the size of the element is increases. The size will be increases If the size is increases means atomic radius is also increases from top to bottom in a periodic table. Here also same, as we move from top to bottom in a periodic table of 13th group, that is a boron family. So boron to thallium atomic number is increases. Little bit exceptions will be there. Now we'll discuss that. And in case of 14th group also atomic radius is also increases. In case of this ionic radius is also increases. Atomic radius is also increases. Here we written that question like the atomic and ionic radii of 13th group elements is smaller than the second group elements. Why? We are comparing the atomic and ionic radii of 13th group with the second group. Second group element andre avu beryllium, magnesium, calcium, strontium, barium, radium. Avu second group element. ಆ ಸೆಕೆಂಡ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ ಜೊತೆ 13th ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ ಅನ್ನ ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಅಟೋಮಿಕ್ ರೇಡಿಯಸ್ ಏನಾಗುತ್ತಾ ಅಂತ ಹೇಳ್ತಾರೆ. Now the question is like that. The atomic and ionic radius of 13th group element is smaller than 13ನೇ ಗ್ರೂಪಿನ ಎಲಿಮೆಂಟ್ ಅಟೋಮಿಕ್ ರೇಡಿಯಸ್ smaller than second group element. Second group element ಗಿಂತ ಏನೈತಿ ಕಡಿಮೆ ಐತಿ ಯಾಕಂತ ಕೇಳ್ತಾರೆ. So point is that here as we move from left to right in a periodic table, size will be decreases. So left to right size will be decreases, top to bottom size is increases. Here will be the second group element. ಇದೇನು ಸೆಕೆಂಡ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ ಅಂತ ತಿಳ್ಕೊಳ್ರಿ, ಇದು 13ನೇ ಗ್ರೂಪ್ ಅಂತ ತಿಳ್ಕೊಳ್ರಿ, 13th ಗ್ರೂಪ್ ಅಂತ ತಿಳ್ಕೊಳ್ರಿ. Compared to the second group and the 13th group, size of the 13th group should be what? Small, because left to right nuclear charge is increases. The increased electrons are filling in the same subshell, hence the electrostatic force of attraction between the nucleus and the electron will be more, hence the size will be decreases from left to right. Here the answer will be there. On moving left to right in the periodic table across the period, you can call nuclear charge is increases by 1 unit. Hope you know that. Increase ಎಡದಿಂದ ಬಲಕ್ಕೆ ಹೋದಂಗೆಲ್ಲ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಒಂದೊಂದು ಯೂನಿಟ್ ಹೆಚ್ಚಾಕೊಂತ ಹೋಗ್ತತಿ. ಅಂಡ್ ಹೆಚ್ಚಾದಂತ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಸೇಮ್ ಶೆಲ್ದಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ತುಂಬ್ಕೊಂತ ಹೋಗ್ತೀವಿ. ಹಿಂಗಾಗಿ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ಸೈಜ್ ಏನಕ್ಕಂತ ಬರ್ತೈತಿ, ಕಡಿಮೆ ಆಕೊಂತ ಬರ್ತೈತಿ. ಸೈಜ್ ಕಡಿಮೆ ಐತಂದ್ರ 13th ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ ಹ್ಯಾವಿಂಗ್ ಅ ಸ್ಮಾಲರ್ ಸೈಜ್ ಅಂಡ್ ದ ಸೆಕೆಂಡ್ ಗ್ರೂಪ್, ಇಟ್ ಮೀನ್ಸ್ ಅಟೋಮಿಕ್ ಅಂಡ್ ಅಯಾನಿಕ್ ರೇಡಿಯಸ್ ಆಫ್ 13th group should be less than the what? Second group. That is the point here we written. And on moving down the group ಬಂದಂಗೆಲ್ಲ the group atomic and ionic radii increases with exception of gallium. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಎಡದಿಂದ ಬಲಕ್ಕೆ ಹೋದಂಗೆಲ್ಲ ಸೈಜ್ ಕಡಿಮೆ ಆಕೊಂತ ಬರ್ತೈತಿ, ಯಾಕಂದ್ರೆ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಹೆಚ್ಚಾಕೊಂತ ಹೋಗ್ತೈತಿ. Top to bottom in a periodic table size is increases, hence the atomic radius and ionic radius is also increases. That point we written here with the exception of gallium. Gallium ಒಂದು ಬಿಟ್ಟು, gallium ಅಂತಂದ್ರೆ ನಮ್ಗ ಫಸ್ಟ್ ಒನ್ ಯಾವ್ದೈತ್ರಿ, ಬೆರಿಲಿಯಂ, ಅಲ್ಯೂಮಿನಿಯಂ, ಗ್ಯಾಲಿಯಂ, ಇಂಡಿಯಂ ಅಂಡ್ ಥ್ಯಾಲಿಯಂ. ಸೊ ಗ್ಯಾಲಿಯಂದಾಗ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರ, ಇಫ್ ಯು ರೈಟ್ ದ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಆಫ್ ದ ಗ್ಯಾಲಿಯಂ, the d subshell will be there. ಇಲ್ಲಿ d ಎಲೆಕ್ಟ್ರಾನ್ ಎಷ್ಟು ಹೊಂದೇವ ಅಂದ್ರೆ 10 ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಹೊಂದಿರ್ತದೆ, ಹೌದಾ? ಸೊ ಇಲ್ಲಿ ಸ್ಕ್ರೀನಿಂಗ್ ಇಫೆಕ್ಟ್ ಏನಕ್ಕಂತ ಬರ್ತೈತಿ, those electrons are failed to screen the nucleus, hence the more attraction are the outer electrons having a more attracted towards the nucleus, hence the size will be what it is, less than what we expect. Expectation ಗಿಂತ ಅದು ಏನೈತಿ, ಸೈಜ್ ಕಡಿಮೆ ಐತಿ ಅಂತ ಹೇಳ್ತೀವಿ. That is the one more exceptions about the atomic and ionic radii of that 13th group element. And now we'll discuss that how it will be and why the gallium having less atomic size than the aluminium. So question is that why atomic radius of gallium is lesser than the aluminium. So usually ಏನಾಗಬೇಕಿತ್ತು ನಮ್ಗ, ಟಾಪ್ ಟು ಬಾಟಮ್ ಹೋದಂಗೆಲ್ಲ ಬೆರಿಲಿಯಂ, ಅಲ್ಯೂಮಿನಿಯಂ, ಗ್ಯಾಲಿಯಂ, ಇಂಡಿಯಂ ಅಂಡ್ ಥ್ಯಾಲಿಯಂ. ಟಾಪ್ ಟು ಬಾಟಮ್ ಹೋದಂಗೆಲ್ಲ ಅಟೋಮಿಕ್ ರೇಡಿಯಸ್ ದೊಡ್ಡದಾಗಬೇಕಿತ್ತು, ಸೈಜ್ ದೊಡ್ಡದಾಕೊಂತ ಹೋಗುತ್ತಾ. ಅಲ್ಯೂಮಿನಿಯಂ should have a less atomic radius than the gallium. The point is that here atomic radius of gallium is less than aluminium. ಅಂದ್ರ ಅಲ್ಯೂಮಿನಿಯಂ ಗಿಂತ ಗ್ಯಾಲಿಯಂ ಏನೈತಿ, ಕಡಿಮೆ ಅಟೋಮಿಕ್ ರೇಡಿಯಸ್ ಅನ್ನ ಹೊಂದೈತಿ. ಹಂಗಂದ್ರೆ ಯಾವ್ದು ಹೆಚ್ಚು ಹೊಂದೈತಿ ಅಂದ್ರೆ ಅಲ್ಯೂಮಿನಿಯಂ ಜಾಸ್ತಿ ಹೊಂದೈತಿ. ಯಾಕಂತ ಡಿಸ್ಕಷನ್ ಮಾಡ್ಬೇಕು ಈಗ. Gallium has inner n minus 1 d electrons. If you write the electronic configuration of the gallium, the d10 will be there, that is the d orbital will be there. Gallium has inner n minus 1 d electrons. These electrons do not shield the nuclear charge properly due to poor penetration effect. As a result of increased nuclear charge in a gallium, its atomic size is less than that of the aluminium. ಇಲ್ಲೇನಾಗುತ್ತಾ ಟಾಪ್ ಟು ಬಾಟಮ್ ಹೋದಂಗೆಲ್ಲ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ವಾಟ್ ಇಟ್ ಈಸ್ shielding effect or screening effect ಹೆಚ್ಚಾಕೊಂತ ಹೋಗಬೇಕು. ಸೊ ನೀವು if you write the electronic configuration of the gallium, d orbital will be there. These d orbital electrons are failed to shield the nuclear charge. ಅಂದ್ರ ಡಿ ಇದಾಗಿರ್ತಕ್ಕಂಥ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಕ್ಕವು ಅವು ಶೀಲ್ಡ್ ಮಾಡುದು ಸ್ಕ್ರೀನ್ ಮಾಡಬೇಕಾಗಿತ್ತು. ಯಾವುದನ್ನ ಔಟರ್ ಮೋಸ್ಟ್ ಶೆಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಮತ್ತು ನ್ಯೂಕ್ಲಿಯಸ್ಗೆ ಇನ್ನರ್ ಶೆಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಏನ್ ಮಾಡಬೇಕಿತ್ತು, ಸ್ಕ್ರೀನ್ ಆಗಿ ಆಕ್ಟ್ ಆಗಬೇಕಿತ್ತು. ಬಟ್ ಡಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ ಅ ಪುವರ್ ಶೀಲ್ಡಿಂಗ್ ಇಫೆಕ್ಟ್, ಹೆನ್ಸ್ the size will be less than the what it is aluminum, that we written here. So that the inner d electrons do not shield the nuclear charge properly due to poor penetration effect. Penetration effect in the sense removal of electron, that is s orbital, p orbital, d orbital, f orbital will be there. If you want to remove the s orbital electrons, we need a more energy compared to this one, compared to this one, compared to this one. Here it is, d electrons are having a poor shielding effect. Because of that reason, gallium having a less atomic radius than the aluminium. And here we written the some atomic radius of boron, that is 85 picometers, aluminium and gallium having a 135. It is having a less than the aluminium. That's the reason we discussed about that. And indium, this is about the thallium. The second physical property of that p block element, that could be 13th group element. Now we discuss that. That is the ionization enthalpy. Hope you know the meaning of ionization enthalpy. Amount of energy required to remove an electron from the isolated gaseous atom, that we are calling as a ionization enthalpy. So ionization enthalpy, how it is related to the atomic size? That ionization enthalpy is inversely proportional to the atomic size. Or you can write that atomic size is inversely proportional to ionization energy. More the atomic size, lesser will be the ionization enthalpy. Hope you know that. So from here 13th group, from boron to thallium, the ionization enthalpy should be decreases because size is increases. If the size is increases, means attraction between the nucleus and the outermost shell electron is decreases, hence we need a less energy to remove an electron from the outermost shell. That point you can remember. Here the some variations will be there, now we'll discuss that. Here the size is more, means attraction will be less. Size ದೊಡ್ಡದೈತಂದ್ರ ನ್ಯೂಕ್ಲಿಯಸ್ಗೆ ಮಾತ್ರ ಔಟರ್ ಮೋಸ್ಟ್ ಶೆಲ್ ಎಲೆಕ್ಟ್ರಾನಿಗೆ ಅಟ್ರಾಕ್ಷನ್ ಏನಕ್ಕಂತ ಹೋಗ್ಬೇಕು, ಕಡಿಮೆ ಆಕ್ಕೊಂತ ಹೋಗ್ಬೇಕು. ಕಡಿಮೆ ಆತಂದ್ರ ನಾವು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ರಿಮೂವ್ ಮಾಡುವಂತ ಎನರ್ಜಿ ಏನಾಗಬೇಕು, ಕಡಿಮೆ ಆಗಬೇಕು. ಬಿಕಾಸ್ ಅಟೋಮಿಕ್ ಸೈಜ್ is inversely proportional to ionization enthalpy. The point is that here, if you compare the, here also it is decreases, later we'll discuss about the variations of this one. Now we can compare the ionization enthalpy of this 13th group with the second group element. Second group elements are beryllium, that is magnesium, so that is having a more size, this one second group elements, and these are the 13th group elements. The question is that here, first ionization enthalpy, in the sense if you remove the first electron from the outermost shell, first ionization enthalpy of 13th group element is less than the second group elements. Why? If you go across the period, so at the left to right ಹೋದಂಗೆಲ್ಲ ಸೈಜ್ ಏನಕ್ಕಂತ ಹೋಗುತ್ತಾ, ಕಡಿಮೆ ಆಕೊಂತ ಹೋಗುತ್ತೆ. ಸೈಜ್ ಕಡಿಮೆ ಆತಂದ್ರ ಅಟ್ರಾಕ್ಷನ್ ಏನಾಗಬೇಕು, ಹೆಚ್ಚಿಗೆ ಹಾಕಬೇಕು. ಅಟ್ರಾಕ್ಷನ್ ಹೆಚ್ಚಿಗೆ ಆತಂದ್ರ ವಿ ನೀಡ್ ಮೋರ್ ಎನರ್ಜಿ. ಅಂತ ಕೇಸಸ್ದಾಗ ಸೈಜ್ ಕಡಿಮೆ ಇತ್ತಂದ್ರ ಅಲ್ಲಿ ಎನರ್ಜಿ ನಮ್ಗ ಬಾಳ ಬೇಕಾಗುತ್ತ ಒಂದ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ರಿಮೂವ್ ಮಾಡ್ಬೇಕಂದ್ರ. ನಮಗ 13th ಗ್ರೂಪಿಗೆ ಮತ್ತ ಸೆಕೆಂಡ್ ಗ್ರೂಪಿಗೆ ಹೋಲಿಸಿಕೊಂಡ್ರ 13th ಗ್ರೂಪ್ ಸ್ಮಾಲರ್ ಸೈಜ್ ಅನ್ನ ಹೊಂದ್ಯಾವು, ಸೆಕೆಂಡ್ ಗ್ರೂಪ್ ಲಾರ್ಜರ್ ಸೈಜ್ ಅನ್ನ ಹೊಂದ್ಯಾವು. ಸೆಕೆಂಡ್ ಗ್ರೂಪ್ ಎಡಗಡೆ ಸೈಡ್ ಬರ್ತಾವು, ಲಾರ್ಜರ್ ಸೈಜ್ ಹೊಂದ್ಯಾವು. 13th ಗ್ರೂಪ್ ಸ್ಮಾಲರ್ ಸೈಜ್ ಹೊಂದಾವು. Smaller size means more ionization should be there for the 13th group. The point is that here first ionization enthalpy of a 13th group element is less than the second group element. 13ನೇ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ ಕಡಿಮೆ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿಯನ್ನ ಹೊಂದ್ಯಾವು ಯಾವುದಕ್ಕಿಂತ ಸೆಕೆಂಡ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ಸ್ ಗಿಂತ ಯಾಕಂತ ರೀಸನ್ ನೌ it is evident from the electronic configuration of the 13th group element is ns2 np1. That is we are writing general electronic configuration of that boron family will be ns2 np1. This is general electronic configuration. If you write the general electronic configuration of the second group, that is ns2. This is about the second group element. This is about the 13th group element. General electronic configuration that we written. It is evident from the electronic configuration of the 13th group elements, that is ns2 np1. The electrons has to be removed from the outer p orbital, whereas in case of a second group elements, a valency electron has to be removed from the inner s orbital. ಅಂದ್ರ ಇಲ್ಲಿ 13ನೇ ಗ್ರೂಪ್ ನ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ನಾವು p ಆರ್ಬಿಟಲ್ ದಿಂದ ರಿಮೂವ್ ಮಾಡಬೇಕು. ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಅಂದ್ರೆ ಏನು? ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ರಿಕ್ವೈರ್ಡ್ ಟು ರಿಮೂವ್ ಎನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಫ್ರಮ್ ದ ಐಸೋಲೇಟೆಡ್ ಗ್ಯಾಸಿಯಸ್ ಆಟಮ್. ಇಲ್ಲಿಂದ ಫಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ p ಸಬ್ಶೆಲ್ ದಿಂದ ರಿಮೂವ್ ಮಾಡಬೇಕು. ನಾವು ಇನ್ ಸೆಕೆಂಡ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ s ಸಬ್ಶೆಲ್ ದಿಂದ ರಿಮೂವ್ ಮಾಡಬೇಕು. If you talk about the penetration effect of those orbitals, that is s having more than p, more than d, more than f. If you want to remove the electron from the s orbital, we need a more energy compared to the p orbital. Hence here we are removing the electron from the p orbital, we need a less energy compared to the second group element. Second group element daga ನಾವು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಸೆಕೆಂಡ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ ದಾಗ ನಾವು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ s ಆರ್ಬಿಟಲ್ ದಿಂದ ರಿಮೂವ್ ಮಾಡಬೇಕು. ಇಲ್ಲಿ p ಆರ್ಬಿಟಲ್ ದಿಂದ ರಿಮೂವ್ ಮಾಡಬೇಕು. s ಆರ್ಬಿಟಲ್ ದಿಂದ ರಿಮೂವ್ ಮಾಡಬೇಕಂದ್ರೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಗೆ s ಆರ್ಬಿಟಲ್ ಹತ್ರ ಇರೋದ್ರಿಂದ ಮೋರ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಅನ್ನು ಹೊಂದಿರ್ತಾವು. ಹೆನ್ಸ್ s ಆರ್ಬಿಟಲ್ ದಿಂದ ರಿಮೂವ್ ಮಾಡಬೇಕಂದ್ರೆ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಬೇಕಾಗುತ್ತೆ. p ಆರ್ಬಿಟಲ್ ಸ್ವಲ್ಪ s ಆರ್ಬಿಟಲ್ ಗಿಂತ ದೂರ ಇರ್ತಾವು, ಹಿಂಗಾಗಿ ಅಟ್ರಾಕ್ಷನ್ ಸ್ವಲ್ಪ ಕಡಿಮೆ ಇರ್ತೈತಿ, ಅದಕ್ಕೆ ಇಲ್ಲಿ ಕಡಿಮೆ ಎನರ್ಜಿ ಬೇಕು. ದಟ್ ಪಾಯಿಂಟ್ ವಿ ರಿಟರ್ನ್ ಹಿಯರ್. The electronic configuration of the 13th group element is ns2 np1. The electron has to be removed from p orbital, whereas in case of second group elements, valence electron has to be removed in a s orbital. Hence the first ionization enthalpy of a 13th group element is less than the second group element. And generally if you talk about the ionization enthalpy in case of a 13th group element, generally ionization enthalpy decreases down the group from boron to aluminium. Point is that usually it is decreases, but in case of the boron family some variations will occur. Now we will discuss that. Generally ionization enthalpy or energy decreases down the group from boron to aluminium. ಬೋರಾನ್ ಮತ್ತು ಅಲ್ಯೂಮಿನಿಯಂ ಹೋದೆ ಅಂದ್ರೆ ಯೂಶುವಲಿ ಏನಾಗುತ್ತಾ ಡಿಕ್ರೀಸ್ ಆಕೊಂತ ಬರ್ತೈತಿ. ಯಾಕಂದ್ರೆ ಸೈಜ್ ಏನಾಗುತ್ತಾ ಬೋರಾನ್ ಮತ್ತು ಅಲ್ಯೂಮಿನಿಯಂ ಹೋಲಿಸಿದ್ರೆ ಅಲ್ಯೂಮಿನಿಯಂ ಲಾರ್ಜರ್ ಸೈಜ್ ಹೊಂದೈತಿ, ಬೋರಾನ್ ಕಡಿಮೆ ಸೈಜ್ ಹೊಂದಿರೋದ್ರಿಂದ ಅದು ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಅಲ್ಯೂಮಿನಿಯಂ ದಾಗ ಕಡಿಮೆ ಇರ್ತೈತಿ, ಬೋರಾನ್ ದಾಗ ಹೆಚ್ಚಿರ್ತೈತಿ. ಬಟ್ ಇನ್ಕ್ರೀಸಸ್ ಫ್ರಮ್ ಗ್ಯಾಲಿಯಂ, ಅಲ್ಯೂಮಿನಿಯಂ ದ ಗ್ಯಾಲಿಯಂ ಗೆ ಹೋಲಿದ್ರೆ ಏನಾಗಬೇಕಿತ್ತು? ಕಡಿಮೆ ಆಗಬೇಕಿತ್ತು. ಬಟ್ ಹಿಯರ್ ಇಟ್ ಈಸ್ ಇನ್ಕ್ರೀಸಸ್ ಫ್ರಮ್ ಅಲ್ಯೂಮಿನಿಯಂ ಟು ಗ್ಯಾಲಿಯಂ and then again decreases from gallium to indium. ನಾವು ಗ್ಯಾಲಿಯಂ ದಿಂದ ಇಂಡಿಯಂ ಗೆ ಹೋದ ಮತ್ತೆ ಏನಾಗುತ್ತೆ? ಡಿಕ್ರೀಸ್ ಆಗುತ್ತಾ ಬರ್ತದೆ. ಇದು ಯಾಕೆ ಆಗುತ್ತೆ ಅನ್ನೋದು ನಾವು ಈಗ ಡಿಸ್ಕಷನ್ ಮಾಡೋಣ. So reason behind this, why it is decreases down from boron to aluminium, again it is increases aluminium to gallium, again it is decreases from gallium to indium. Reason behind this one is that the sharp decrease in the ionization enthalpy from boron to aluminium is due to increase in atomic size. This is a very simple as we move from top to bottom, size is increases, it means ionization enthalpy is also decreases. It is inversely proportional to each other. This point we can remember. Next point, in case of gallium, as it contains n-1 d electrons, ನೀವು ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಅನ್ನ ನಾವು ಅರ್ಲಿಯರ್ ಸ್ಲೈಡ್ ದಾಗ ನೋಡಿದ್ವಿ. ಸೊ ಅಲ್ಲಿ ನೀವು ಅದನ್ನ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಅನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಡಿ ಎಲೆಕ್ಟ್ರಾನ್ ಅಥವಾ ಡಿ ಸಬ್ ಶೆಲ್ ದಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ತುಂಬಿಕೊಂತ ಹೋಗ್ತೀವಿ. which have poor shielding effect and nuclear charge is increases. ಆ ಡಿ ಸಬ್ ಶೆಲ್ ದಾಗ ಇರ್ತಕ್ಕಂಥ ಇನ್ನರ್ ಶೆಲ್ ದಾಗ ಇರ್ತಕ್ಕಂಥ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾಗುದಿಲ್ಲ ಸ್ಕ್ರೀನ್ ಮಾಡಕ ಅಥವಾ ಶೀಲ್ಡ್ ಮಾಡಕ ಆಗುವುದಿಲ್ಲ. ಅದಕ್ಕೆ ಪುವರ್ ಶೀಲ್ಡಿಂಗ್ ಇಫೆಕ್ಟ್ ಅಂತ ಕರೀತೀವಿ. ಸ್ಕ್ರೀನ್ ದ ಸೆನ್ಸ್ ಮರೆಮಾಚು. ಇನ್ನರ್ ಶೆಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಔಟರ್ ಮೋಸ್ಟ್ ಶೆಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಗೆ ಮತ್ತು ನ್ಯೂಕ್ಲಿಯಸ್ ಗೆ ಸ್ಕ್ರೀನ್ ಆಗಿ ಆಕ್ಟ್ ಆಗ್ತಾವ. ಅದು ಡಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ಪುವರ್ ಶೀಲ್ಡಿಂಗ್ ಇಫೆಕ್ಟ್ ದಟ್ ವಿ ಆರ್ ರಿಟನ್. ಅಂಡ್ ಅವು ಪುವರ್ ಶೀಲ್ಡಿಂಗ್ ಇಫೆಕ್ಟ್ ಇತ್ತಂದ್ರ ನ್ಯೂಕ್ಲಿಯಸ್ ಗೆ ಮತ್ತು ಔಟರ್ ಮೋಸ್ಟ್ ಶೆಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಗೆ ಏನಾಗುತ್ತ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಜಾಸ್ತಿ ಇರ್ತದೆ. ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಜಾಸ್ತಿ ಐತೆ ಅಂತಂದ್ರ ವಿ ನೀಡ್ ಮೋರ್ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ. ಅದು ಜಾಸ್ತಿ ಐತೆ ಅಂದ್ರೆ ನಾವು ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ರಿಮೂವ್ ಮಾಡ್ಬೇಕಂತಂದ್ರೆ ಜಾಸ್ತಿ ಎನರ್ಜಿ ಬೇಕಾಗುತ್ತೆ. ದಟ್ಸ್ ದ ಪಾಯಿಂಟ್ ಹಿಯರ್ ವಿ ರಿಟನ್. So that is in case of gallium, as it contains n-1 d electrons which have poor shielding effect. Due to that nuclear charge increases, therefore ionization enthalpy of gallium is increases. Aluminum ಗೆ gallium ಹೋಲಿಸಿಕೊಂಡ್ರೆ ಕಡಿಮೆ ಇರಬೇಕಿತ್ತು, ಬಟ್ ಇಲ್ಲಿ ಹೆಚ್ಚಾಗುತ್ತಂದ್ರ ಇಲ್ಲಿ ಡಿ ಸಬ್ ಶೆಲ್ ದಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ತುಂಬಿಕೊಂತ ಹೋಗ್ತೀವಿ. ಈ ಡಿ ಸಬ್ ಶೆಲ್ ದಾಗ ಇರತಕ್ಕಂತ ಎಲೆಕ್ಟ್ರಾನ್ ಸ್ಕ್ರೀನ್ ಮಾಡುವಂತ ಕೆಪಾಸಿಟಿಯನ್ನ ಕಡಿಮೆ ಹೊಂದಿರ್ತಾವು. ಸ್ಕ್ರೀನ್ ಆಗ್ಲಿಲ್ಲ ಅಂದ್ರ ನ್ಯೂಕ್ಲಿಯಸ್ ಗೆ ಮತ್ತು ಔಟರ್ ಮೋಸ್ಟ್ ಶೆಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಗೆ ಅಟ್ರಾಕ್ಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಅಟ್ರಾಕ್ಷನ್ ಜಾಸ್ತಿ ಇತ್ತಂದ್ರೆ ನಮಗ ಒಂದ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ರಿಮೂವ್ ಮಾಡ್ಬೇಕಂತಂದ್ರೆ ನಮಗೆ ಏನ್ ಬೇಕು, ಎನರ್ಜಿ ಜಾಸ್ತಿ ಬೇಕಾಗುತ್ತ. ಅದಕ್ಕೆ ಅಲ್ಯೂಮಿನಿಯಂ ದಿಂದ ಗ್ಯಾಲಿಯಂ ಗೆ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳ್ತೀವಿ. ನೆಕ್ಸ್ಟ್ ಪಾಯಿಂಟ್ ಇಟ್ ಈಸ್ ಸಿಮಿಲರ್ಲಿ ionization enthalpy of thallium is more than the aluminum, gallium and indium. This is due to the presence of 4f electrons in the thallium. If you write the electronic configuration of the thallium, that is a 4f electrons will be there. F orbital ದಾಗ electron ಅನ್ನು ತುಂಬಿಕೊಂತ ಹೋಗ್ತೀವಿ. ಅಲ್ಲಿ 4f electrons having a shielding effect. That is also the one more important point. Ionization enthalpy of thallium is more than aluminum, gallium and indium. ಇಲ್ಲಿ ಪುವರ್ ಶೀಲ್ಡಿಂಗ್ ಇಫೆಕ್ಟ್ ಇರೋದ್ರಿಂದ ಅಟ್ರಾಕ್ಷನ್ ಜಾಸ್ತಿ ಇರ್ತದೆ. ಅಟ್ರಾಕ್ಷನ್ ಜಾಸ್ತಿ ಇರ್ತದೆ ಅಂದ್ರೆ ಅಗೇನ್ ಏನು ಎನರ್ಜಿ ಜಾಸ್ತಿ ಬೇಕಾಗುತ್ತೆ. If you write the first ionization enthalpy and the second ionization enthalpy and the third ionization enthalpy of this boron family, that is the first ionization enthalpy is less than the second ionization enthalpy and this is less than the third ionization enthalpy. That is depends on what it is, size and nuclear charge, and about the if the nuclear charge will be more means we need a more energy. This is about the ionization enthalpy of that boron family. Remaining part of the p block elements we'll discuss in the next class. Thank you.